you can do the same thing with automation, that
Yep.
reducing the data. But that's something that I've been looking very much into, and also increasing the quality of the data in post processing. That if you see an object coming in here and it loses the tracking ID, and a new object
Yeah.
appears within 100 milliseconds right here and goes here, you can actually tie them together before you even send it back into the system.
Yeah.
So if you need to, when you understand how the data behaves, then you can do actually increase the quality by fixing some of the flaws.
How's everyone doing today? My name is Quang Trin, and welcome to the I2P podcast. It's short for Innovation in Progress. The purpose of this podcast is to bring a lot of technical information from a varying array of emerging technologies and have conversations with folks that are experts or that just have a passion for the technology. Our goal is to hopefully bring some awareness, but also take that technical information and make it more digestible to our audience. So I hope that you find this not only educational but entertaining. Each of our guests and myself work for a particular organization, and the discussions on the topics we make on this podcast don't necessarily reflect the opinions or represent the opinions and perspective of those organizations. And hope you guys really enjoy the type of content. If you guys would please comment on the videos, whether you like it or not. Give us suggestions on content that you guys would like us to have. I currently chair for the ASIS Emerging Technology Steering Committee for ASIS. And there's a lot of individuals there that have a ton of knowledge around different technologies, ranging from AI to robotics to other types of sensor data out there. So we want to be able to kind of spread and educate our content in a very digestible way. And I think everybody now has some sort of podcast or conversational podcast where they kind of break down some of the technical stuff into layman's term. So I hope that you guys, feel that this is a very insightful series. I do apologize in the beginning when we recorded this first episode. Didn't realize there were some audio issues with the recording, so there are some dips and valleys where the audio might come in and out. So I do apologize up front ahead of time, but we'll probably get that addressed over the next couple of series of podcasts that we'll end up recording. So with that, I hope you guys enjoy this first episode with a conversation with a very good friend of mine, Fred Juhlin at Access Communications. So have a great day. Thank you for stopping by.
Um, I'm the old timer at Access. I've been at Access. April 1st is going to be 29 years.
Oh wow!
So
Yeah.
I started off as a software engineer. I had 7 years software development, prior to starting at Access. Um, but I kind of after a while I wanted to move up.
Mm-hmm.
From a systems perspective, I find solutions and use cases much
Yep.
more interesting. So the role I've had the last couple of years as a global senior consultant, to me, that's all about building knowledge and sharing that knowledge,
Mm-hmm.
and assisting anyone who needs assisting from any product integration, cybersecurity, or any of these things. And just love tinkering. It's very hard for me to separate the things I do at work
Yeah.
and the things I do at home. I love home automations and playing around with various kind of use cases and building systems and solutions and see how much value if I use them after 6 months. If not, that was not any value at all. But some of the stuff that I've been that it seems to be really nice. Some of the related to AI
Yeah.
recently that I've been working on.
No, that's
So I think that's a I think it's a short description,
yeah.
but
No, no,
it's
awesome. Thank you, Fred. I mean, I'm coming up on 12 years with Access, and I remember when I joined Access and meeting you. I think we started off talking a lot about cybersecurity and how important that was for our devices, and I was really, trying to beat that drum with cybersecurity of anything because of the devices being on the network, right? And
yeah.
then really we started interacting more because I started getting into understanding ACAPs, and I know you were like a huge resource when it came to developing and understanding ACAPs and getting some things done with our devices beyond what was already available out there. You know, we had partners that developed their ACAPs, but I think what you were able to kind of drum up was some interesting thoughts and ways to use the device, and that really intrigued me. And then the ACAP kind of grew to, we talked about like Node-RED and how things started to get really I think high level or like very automated with like Node-RED, and even now with like Python, right? Like I think the next generation, like I'm teaching my son, my 10-year-old son, Python. You know, like I don't think he needs to learn like Fortran or Pascal like I did in college back in the 90s, you know? And it seems like Python seems to be like the really good scripting, because I remember.
It's either Node.js or
Yeah,
Python, but from it's a scripting thing.
yeah,
And if you go back to my ACAP, because I was the product manager at Access at that time that
yeah,
introduced ACAP in was this 2009, I think,
I think so. Yeah, yeah,
and then the version 2 in was that 2011, maybe something like that.
yeah,
And at that time I wanted to understand, what are the possibilities and limitations of ACAPs. And the only way to learn is, roll up your sleeves
oh yeah,
and show them, describe how the SDK that I've ordered,
yeah,
and show me some example code. And I looked at that code, and I hadn't done any software engineering
hmm,
since up to that point. And I looked at the code and says, I know where to put my stuff in here, my code.
yeah,
And then I started, that's interesting. And I built, one ACAP and two ACAPs and three ACAPs
yeah,
just for the fun.
oh yeah,
So I got the passion back into software development, just doing it for myself, not having someone breathing down my neck and things like that. And after a while, I have 10, 15. I'm sure there's some value here.
yeah,
And I decided, well, why not just publish them, and just see that people can use them, if they want to. And been doing that ever since. And then Node-RED came in, and
yeah,
understanding how. So to me, it's all about how can I reduce the threshold so integrators, that would be an engineer
yeah,
with skills, with engineering skills, but he's not a software developer. And how can I lower the threshold that he can build solutions around, and
yeah.
additional components are needed, either ACAP, node flows, or things like that.
Yeah, and then now we segue into the exciting stuff for me, which started right around like 2016 and 2017, where I really was. I've been tracking AI for a while now, and then around that time was when I got really excited with all the innovations in CNNs and tensors, and then when we brought out our first camera with an actual NPU, that was very exciting, and the fact that we had the ACAP platform really inspired me and really started to trigger some things internally with me, and then even some of the colleagues that I talking to about like, hey, this is some really fun stuff to do with computer vision, and this is like, to me, like the next generation of things that we can do with images and video, and here we are in 2025, and there's a lot of amazing things that we can do on the edge, and for me back then it started with just playing around with a Raspberry Pi, playing around with some of the really NVIDIA GPUs that I have on my gaming PC, and then now the fact that these things can be run really efficiently on our cameras, it got me really intrigued to say, what can we do to really push its limit, right? To do
Yeah.
what it can do outside of the security and safety space, because I think what Axis has done really well is create a deep learning model for what suits the security industry, which is an object detector for people and vehicles. But as you and we talk back and forth about experimenting with other objects, there's a lot of flexibility there,
Yeah.
that can be explored not only by us as playing around with that, but I think also with the end customers or even SIs. And I think the next biggest leap for an SI in the security space or anyone in other industries is to make this much more easier to deploy, to train, to execute on. And I think that's the next big bridge, kind of like how we were talking about, getting to like Node-RED and making it much more graphical user interface, making it to where somebody really doesn't need to know the technical aspects, but just knows enough of the overall architecture to get these things done. So
Yeah.
Yeah.
So a lot of this, what the customization that if you look at the common cases and there are already tons of models out there,
Yeah.
detecting vehicles,
Yep.
detecting humans, heads, and all that stuff. But there's so much more than when you can be using the cameras as a sensor by detecting something specific. That could be, quality
Yep.
assurance that everything is put together, or all of these things. And I was kind of slow in that because I was all the ACAPs that I did were more integration components that taking the getting into the data of the camera, getting into the VOD, the video object detection data that's already in the camera, and pushing that into other kinds of systems that want to consume that and that would be like a influx database, and then or a Mongo database, and then you can build your clients and visualizing the data, or doing a forensic search, dwell path heat mapping, flow heat mapping, all that stuff. And you can do a lot of things with that data that the camera produce.
Yeah, and that's really the key here, right? Is like the transition between just a video source to actually a data source, and the video is just one type of data. I think the days of like 5 to 10 years ago, where we had these applications to do all these heat mapping and things like that, you can easily get that with just having a good object detector of people and vehicles, and then the logic to get everything that you talk about is easily there once you extrapolate it from an actual like stored database, whether it's on the device
so
or
what
on
I
the
noticed,
cloud, right?
what I noticed is the processing, the data that the analytics produces needs processing depending on the use case, and especially if it's one of these data like where the first consumer is a database and all the use cases is querying the database, and how to get that data depending on what queries that you're going to be doing towards the database, and transforming that. So, and you can do a lot more with the data and I find this interesting when you start collecting all of this data, like I've been doing, just all the cameras that I have at home, just pushing that in and finding new use cases in the massive amount of data that you didn't know that you had. Because if you're looking at only at that specific event or that data coming in, that use case is not there. But when you collect all of it, a lot of data, then you start finding a lot more use cases. But I was kind of slow on the training my own models. But it wasn't until the spring where I said, where's the next area that I see there's a gap that maybe I can find ways to simplify and reducing the threshold to engineers. And AI was, that was clear to me. So what I did, same like you do, you're having your gaming PC. I bought a used gaming PC just for the graphics card. Removed Windows, installed Linux, and made it to like an AI server. So I wanted to test with playing with my own LLMs, large language models. I like to have everything contained. That yes, I love ChatGPT and Claude. I use them constantly when I develop stuff. But for some stuff, you want to have a more personal stuff. So LLM was one of them. The second one was training models in general. And then the third part was, once I understood how to train the model, how can I get that into the camera and run that model inside the camera? And that has been, evolving. And, and turns like you can do some cool stuff. We're talking, you can detect anything. So someone approached me and said, I have a customer that wants to be able to detect what do you call them? The battery driven, these bikes that you stand on,
right? Or the
scooters,
e-scooters,
like e-scooters. I'm not sure, maybe they had a city that they had problems with this. Do you know of any models? No, maybe I don't, not that I've seen. And I said, but if you find a data set, I can help you train that model. And then he found it because there are tons of data sets, open source data sets of a lot of things. And did the training on my server. It was like for 5 hours. Got that model, put that in an ACAP, and then just send them. Here you go. Want to try this one? and that's how easy I want it to be. That to get that to be able to quickly verify, then we come into the quality. Is the quality good enough?
Yeah.
And I say I have no clue how this performs.
Yeah.
You have to try it.
Yeah.
And I think that area is something that we can discuss a lot with
I
around
think so
is
too, because I think, as hobbyists learning to train a model and then test it, I think the biggest aspect of this is what are the tools necessary to bench it, right? Because I think at the end of the day, with the end customer that wants a particular model to detect certain things, from my perspective, I always ask them, what's your tolerance for the efficiencies of this? Because it's not 100%. As much as we love all the
no,
results that we
analytics
see,
is a
yeah,
guessing game.
it is. It is. It's all math. It's all statisticals. And the fact with statistics is you try to get that to as much as one meaning true or zero being false as much as you can, but it's never going to get to an absolute result,
And
right?
especially in a camera environment
Yeah.
where you have different seasons, different lighting conditions, and all of
Dynamic.
that
Yeah.
stuff.
Yeah.
It's so, and I've noticed this too, is if you're going for a non-critical or a critical,
Yeah.
and the critical is so much harder
It
to
is.
do the validation that it works. A non-critical, if it missed, the world didn't fall apart.
Yeah.
But so, and this is something that I've been looking into also is, especially when you're doing for the cameras, because I started off trying to use TensorFlow
Hmm.
to train my model. And I spent about a month trying to get everything working. And TensorFlow was all the, what do you call it? All the versions of all the packages had to be, on the last digit and everything.
Hmm.
So it was really hard to get anything to work. And then I switched over to YOLO, and then
Yeah.
oh my God, this is easy. This is how it's supposed to be, and the scripts and all that. So that was fairly simple, but you do train into what you call a PyTorch
Yeah.
file, and depending on the models, you have different model size. Describing this as how many parameters are
Yeah.
there inside the model. And you have nano in YOLO. You have nano, which is about
Hmm.
1.7 million parameters or weights. That's
Yeah.
what they call them. In a small, it's around 7 million. Medium, it's 20 million. I don't know how many on a large model size. And the larger model you get, the less it will hallucinate.
Yes. Yeah.
But it also takes more power, more resources. But so you're getting this PyTorch, and in YOLO you can have you typically have three directories of images. One is the training images,
Yeah.
and one is the validations. So
Hmm.
during training, it will build a model, and then test that towards validations
Yeah.
images that is really pre-labeled and saying it said, is this a car? And then the validation says no, it was not a car. So then it tweaks and keeps running that. And you do this for a long time in order to all the parameters are
Yeah.
stabilized. Once you have the model, you can use the a test library with images and seeing how well it performs. The thing is that in order to get it to work in the camera, you have to export it into a TF light
Yeah.
and quantized,
Yeah.
meaning is you're going from floating point to whole numbers to
Yeah. To
integers.
integers. Yeah.
Yeah. How much did you lose during that process?
Yes.
And that's a tough one.
That is. Yes.
Of course, you can have it on your server and running a TensorFlow T-Flight on
Yep.
the test images. I haven't found any good tools. I built my own tools
Yeah.
to do that. But it's that transition is kind of hard to predict exactly what quality you're going to get. That your PyTorch was working well, very,
Yes.
very well, but how well did the T-Flight work? It's
Yeah.
so
Yeah.
I'm sure I'm not an expert. I'm sure there are tons of tools out there that you could use. I typically build my own scripts with
Yeah.
Claude 3.5.
Yeah.
I need a script that takes these images, runs a TensorFlow,
Hmm.
a TF Lite, and then compare it to that.
Yeah.
And then
It's amazing now, especially with helping with coding, that I use Claude and I use Copilot. So like when I'm building Python scripts for Vapix integrations, like it pops up the APIs already for me as it's predicting it already. I'm like, this makes it easier, and I'm just validating and checking that everything all works. So I think from an AI perspective, they're going to use AI in the actual coding process of PyTorch to start to help you with all this, like probably in the next year or so. I think a lot of tools now are using that just to look at previous code and see if they can accelerate the coding aspect of it. But you're so
yeah,
right about testing these on, like, on a computer, on a server, and then now when you want to try to bring that down to an edge device like a camera like ours, you have to quantize it, you have to optimize it a little bit, and then you are going to lose some precision because usually devices like these don't really handle floating point that well because there's not enough processing power. So when you convert floating point to whole numbers, integers, you do lose
yeah.
precision, but then a lot of times that precision might not be, and you have to test it. You might not see that huge of a gap in precision when it comes to detecting of certain objects that you're training on. So all that is almost like you have to make sure you validate. you know?
Yeah.
Yeah.
So besides that, there are two other aspects that you have to. It's the one model size is one of them,
Yeah.
and it's all about, are you going for high frame rate
Yep.
inferences, or are you going for quality?
Yep.
And that is a decision that you have to make, and also, so the model size and then the input resolution.
Yeah.
How big are the images that are
Yeah.
going to be
And this is
inferenced?
where our conversation started, because I was asking you about what you were doing with the YOLO models, because I think when I look, because I reference everything in our GitHub page in terms of like what's the recommended models. So when we see the performance of a model and what GitHub and our Access team members have stated, for I think the target was about 10 frames. So you're looking at about was that 200 milliseconds, right? Or no, 100 milliseconds. Yeah,
No,
10
yeah,
frames is
even
100,
faster.
milliseconds performance or better. But
Yeah.
but then you can still run some more, a model that's 200 milliseconds on it. It's just that I think it depends on the use case, right? Like you were just stating,
Yeah,
when it comes
because
to,
the
yeah,
axis, the analytics and the camera are targeting surveillance, and a
exactly.
lot of that is related to tracking.
Yes,
In order to get a good tracking, you need to have tight inferences
you do.
in
Yeah.
order to. So if you have 1 second in between, you wouldn't be able to distinguish
No,
if it would be the same person or if it moved or
exactly.
whatever.
Yeah.
So you need to have very quick. The others, and then you have the use cases that are not, they're slow changing.
Yes.
A parking space,
Yeah.
the inference could take 10 minutes, and it would still, work well.
Yeah.
Um, and I'm trying to, so the thing that I'm not doing tracking at all.
Yeah.
So a lot of the use cases that I'm looking into is just detection.
Hmm.
And I'm trying to go for 200 milliseconds
Yeah.
of inference time. And that depends on, so I can use a medium-sized
Hmm.
model, and with a pretty high resolution,
Yeah.
like 1440 by 1440. I don't know. I picked that one because
Yeah.
there's an image resolution that I can use that, and that is really high resolution. So like one of the in my training or teaching myself, I downloaded a data set of hand gestures.
Yep.
It's called Hagrid, which is an open source. Um, yeah, of 20 hand gestures, thumbs up, thumbs down, 1, 2, 3, 4, 5, all of that stuff. And, figure, is there a use case? I don't know, but at least I have a project, I have data set. There's like 650,000 images in this data set. So it's a huge data set.
Yep.
And I wasn't using the complete data set because that would take me days just to download it. Training this data, and then started figuring out, okay, how far away do I, if I use a
Excuse me.
small model with a small resolution, how far away can I stand from the camera to still detect?
Yeah.
Bless you.
Oh, sorry. Yeah.
So how far away from the camera? And I wanted to be able to stand as far away as possible. And then I decided to go for a medium-sized model and a really high resolution, and getting around 200 milliseconds on that. I tried it on an ARPEX 7
Yep.
only on the CPU,
Mm-hmm.
and that took about 6 seconds for the
For it
ARPEX
to,
7
yeah.
to make one inference,
Yeah.
which is fine if you're, but not maybe for hand gestures. You
Yeah.
want a little quicker, and then I started, using. So I was looking for the use case on hand gesture, and I said, is there a use case where users interact with the system with hand gestures? And I'm sure there are,
Mm-hmm.
but I use it at home to control my Sonos speakers. So
Okay. Yeah.
so this
Nice.
is 10% volume,
Yeah.
20% of 30. This is play,
Nice.
and this is stop. And I think this one's next.
Yeah.
If I don't like the tune, I'll just do this, and it will just skip to the next one. And I just found it so liberating.
Yeah.
Not so when I'm working and somebody comes in and I'm listening to music and I have my Sonos speakers kind of high up here,
Mm-hmm.
that I can just go like this, or the phone rings. I'll just put up my hand. I don't have to look for the mouse or
Yeah.
clicking or any applications and stuff like that. But I'm sure there are a lot of use cases
Yeah.
where that can be
No,
done.
it's yeah.
But coming back into that I decided I wanted to be able to stand as far away from the camera as possible,
Mm-hmm.
meaning that I need high input resolution,
Yeah.
and preferably maybe so I don't know, maybe a small model would have worked. So this is something you have to try out yourself, where it comes, I think, with experience.
Yeah.
After a while, you kind of know where the ballpark figure should be.
Yeah.
But
I
at least
know.
these are the things that you have to consider when you start training it. And some training like that hand gesture, when I do training, you can also tell how many times should it look at the data set,
Mm-hmm.
called an epoch.
Yeah.
And the more epochs, after a while, gradually the learning curve, starts flattening there. But I was doing like 300, and it took almost 2 days
Oh wow.
to do the training on the machine that I
Yeah.
have.
Yeah.
And then he said, well, maybe I wanted to change the resolution. Oh, I got to do the training again.
And that's where majority of the resources are with a lot of these models is in the training. The training is
Yeah.
what probably takes up the most time consuming, the most processing, and then once you quantize it down and you're executing on it, that's that right there is where you see a lot of optimization happen to where the models actually can work on a lesser
Yeah.
device, to the point where I know that even some models can run on the cloud just using CPU inference, right, instead of GPU.
Yeah.
So it all depends on the use cases, on how quickly you need the data, the output. But I think also now with IP cameras going from high resolution, it's all about understanding what do you have as your source to do the inference on, and how often do you need that in order to reduce the amount of errors, right? Because like going back to how we do a lot of detection, so we want that 10 frames per second inference, because in those 10 frames, if it's detecting a person with a red shirt, 2 of the frames might say it's a blue shirt, right? So
Yeah.
you need to have more data to say, oh yeah, it's not a blue, it's actually a red shirt, and
Yeah.
that gives it better confidence, right? So it really depends on what you're doing, and you're correct, because if you're not tracking anything and you're just doing object detection, and if the movements are not like depending on the use cases, if it's not a lot of things that are happening dynamically or moving in the environment, you might be able to run a much more bigger model that doesn't infer as quickly, because because the scene is not going to allow you to have, that's going to cause that type of error, right? Because it really, for me, it comes down to the scene and the environment, and really determines what's probably the best model to use based on what the customer
Yeah.
is looking for. Yeah.
So if you take like PPE detection, personal protection equipment, that are you wearing a
Yeah.
helmet? Are you wearing a web? I've been playing around with that. And what I noticed, that I do need a high inference time, because the time the people, I'm not tracking the people, but I need enough time to get a positive
Yes.
detection. So a couple of seconds, and in that time, I would like to have 30-40 second, or for 30-40 images at least.
Hmm.
So in that, I want to have it tight. But if detecting a person laying down, that could take 10 seconds, so that wouldn't matter.
Yeah.
If you get high quality after those 10 seconds, that's sufficient.
Yeah.
But so it's all back to the use case on this stuff.
Yeah, yeah, and I think there's also, from my perspective, a shift now too, because the end customers are starting to realize the power of the technology, and they're realizing that it's up to them to kind of determine their use cases to see how to apply these different AI models to what they need, right? Because I think that's kind of like the big I think epiphany right now that's happening, that a lot of end customers are realizing how powerful AI has become, not just the large language models, but also the video and the images and what's happening in computer vision. And I think that's where it's also very challenging, right? Because as a vendor that's trying to supply some of the solutions, it's like what do we tackle? What do we go after? Because there's so much flexibility and so much customization now in the customer's hand to apply this, and also the technology and the architecture is constantly changing. What's going to be the most beneficial? Because I think at the end of the day, we kind of went back to training takes a lot of processing power, a lot of energy to do, and also it's not really sustainable to have so many servers out there doing certain things on AI models and getting the results that you need if the overall cost of the equipment plus running the equipment, it doesn't really give you the return on investment that you need. So for us, when I look at it, is like our devices are freaking low power, right? You're
Yeah.
talking 5 watts at most for most, and some cameras that are outside are maybe 10, 15 watts. PTZs are much higher, but these are low consuming devices. So to try to do a lot of it based on the power draw that it has, there's usually a balance there, right? From my
Yeah.
perspective, there's usually a balance there. I know everybody wants to put so much power to the edge, but if you're talking about a customer that needs to do something in their facility and they have to deploy hundreds, if not thousands, those device power consumption can add up an annual costs and overall running and maintenance and all this stuff. And we know heat is the enemy of camera sensors. You never want to have that generate so much heat because you're going to degrade the quality of the image. So we really
Yeah.
have to see that there's a good balance. I hope the industry goes that way, not just Axis, but the whole industry understands that there needs to be a good balance so that you get the best and you squeeze out the most out of these AI models based on what's available processing at the far edge.
Yeah. So, and then you can have the two-tier analytics where you're running the model in the camera. Uh, Instead of sending, 30 frames per second up
Yep.
to a server in cloud
Yep.
and doing inferences on every image, because that is extremely costly over time.
Oh yeah.
But if you can do the basic detection that we need to take a close look on this image, and then you send up that image
Yeah.
and do with a large resolution and all that stuff,
Yep.
and really, and you can shift here, but running the stuff on the edge is so much more efficient than sending the image back and getting the data
and
also.
and I think if there's a way to we optimize these models to do what it needs to do. I think the other value of this, which I'm starting to see already in Axis devices, is metadata, right? And that metadata is very rich. It's also a lot of noise, but it's also can be very rich, and it can be consumed in a much more lightweight way and still provide the same type of output with certain things that customers are looking for when it comes to the things that we talked about earlier about like counting and heat mapping. Because if the edge models are performing at an efficient level, you're able to get that data, and that data is more in the kilobits versus the megabits when it comes to analyzing 10 frames or even 30 frames worth of images on a server on the cloud, right?
So that's why I see pre-processing
Yeah.
and trying to limit or reduce the amount of unnecessary data.
Yes.
So if you take, like, if you're doing counting, you can take all the detections and then you're trying to build your tracker and seeing if it crosses a line or whatever, and that is going to be a lot of data. But if you can go there and saying, I just want a path, so once that object leaves the scene, you get one data structure saying, or an array of positions that
Yep.
it's been at, where it started, where it ended, what color it was, what class it was, and all that stuff. Just reducing the bandwidth to a fraction
Hmm.
of sending all the continuous object detections. But that also depends on if it's a post-processing application
Yep.
the data is going into, or if it's an automation. You can do the same thing with automation, that
Yep.
reducing the data. But that's something that I've been looking very much into, and also increasing the quality of the data in post-processing. That if you see an object coming in here and it loses the tracking ID, and a new object
Yeah.
appears within 100 milliseconds right here and goes here, you can actually tie them together before you even send it back into the system.
Yeah.
So if you need to when you understand how the data behaves, then you can actually increase the quality by fixing some of the flaws in the detection.
Yeah.
But another area that I've been looking into is the sending into a multimodal. You're taking an image from a
Yep.
camera, sending that into a multimodal, and what's in this image, and
Yes.
then you get a text-based what it finds there. And I think this is something that we're going to see a lot more in the future.
Yeah.
At my server, I do that inference it takes about 2 seconds per
Okay.
image.
Yep.
So it's still very slow and resource demanding.
Yeah.
But
And
I think, yeah, when are we going to have running an LLM inside a multimodal LLM?
that
That's what I think. That's where we're heading somewhere in the future.
yeah, yeah, I think it's but technology moves at such a fast pace. There's a lot of things that we can talk about now, and I think in the next couple of years it could be a reality, right? Because it's
Yeah.
moving so fast. And just like what you're talking about with the multimodal, I know talking to several folks at Axis, we've done some experimentation of just sending the consolidated metadata and the best snapshot to like Chat GPT or Gemini that is a multimodal version of that, not just the text, but that they can analyze the image and spit back an output based on the analysis of that consolidated metadata with the
Yeah.
best snapshot. And I think that is very powerful, a way to kind of show pre-processing at the edge, but also tying it to either an on-prem or a cloud multimodal model to do post-processing. And the latency is really not as bad as a lot of people think it is when it comes to getting the output of what we're looking for, right? Even if it's something as simple as sitting it at a consolidated metadata of just like vehicle objects and asking ChatGPT or Gemini, what's the make and model, just to see what they would infer on that best snapshot, because
Yeah.
I think something like that is already very, very powerful. And I think it really speaks to where what I have been talking to the security industry over the last year is that I think these object detection models that are detecting people and vehicles are going to be the standard, just like how VMD, video motion detection, became the standard for when we switched from analog to IP, and that really changed the makeup of recording video. And I think this is the next leap where these object detectors are going to be the standard in every camera out there. And then the next standard I see is this really natural searching of data, because I
Yeah.
think that's the next biggest thing, where right now
So
a few
and
few,
then
few
I have
people
a
have it, but I
uh,
think it's gonna be really like mainstream.
it's
Yep.
it's really
Yeah.
expensive, but
Yeah.
so someone said to me, I want to go into my system and I want to say that if you see a dog without a leash,
Yeah.
send me an email or notify on this. That's all I want to do. I
Yeah.
just want to tell it, if you see a dog without a leash,
Yeah.
send me an email.
Yeah.
uh, I don't want to have, drop boxes
Exactly. Yep.
and drawing areas
Yep.
and selecting it. I just want to tell it what to do. And I've been experimenting with that too, just collecting all the data that I have in my databases
Yep.
and having where I can start speaking to it. And then on my phone, I would say, show me all the cases where a person with a red jacket walked left in the
Mm-hmm.
last 7 days.
Yep.
And that wasn't too hard. I didn't need an
Yeah.
LLM because there's some key words in there:
Yep.
red color,
Yes.
direction, timing,
Yep.
and then just making a lookup in the database and then sending me a short list of all the video clips that I can go through. And it's going at such a high speed. It's hard to follow what
Yeah.
is going on. It's
And
unbelievable.
and that's why, for me, not only the future of search, but the future of building out events and alerts is going to be so natural. It's not going to be like you're saying, this whole process of this wizard and getting the logic going and all this stuff. It's going to be a very natural process for a security director to just easily say, hey, here are all my pain points, like just let me know when this happened at whatever and it's going to be very natural. It's not going to be and because it's going to be very natural, there's so many use cases that our customers are going to be able to solve, because they're like, well, I never thought of that. Because now that I can speak naturally into it and ask for it, now they're going to be very creative to go, okay, these are where my pain points are, and these are the alerts I want to get, or these are the information and the reports I want to get from my system. And it's not just the video system. You tie that into access control, you tie that into building automation and building sensors, and it just becomes very powerful to aggregate all that data and correlate that, and then provide that back to an end customer that can just easily work around with it. I think that's the next generational leap that I see, is making that interface very natural and very easy for the practitioner. And that's just going to make them more creative to figure out what are the things that they can solve with the systems.
Yeah, and it's one thing that is like, we can detect stuff in the video, but as I said earlier, that once you have a lot of data, then you can start finding new use cases in that data. So something that I have in my that I want to look into, that because I collect all this data, all these paths.
Yeah.
Can I start making predictions? Just analyzing, getting that data into an analytics that can analyze all this data. And I'm sure there are tools out there that can do this, but understanding that, could I actually, if I recorded my street outside for a year, would I be able to ask it to predict when is the next car going to drive by? Is there? I don't know. Maybe it's possible.
Actually, if you take out, like I've done data analytics just from data itself, from structured data from Excels, and and when I took that class, it was talking about like predictions, financial predictions. So I think I know we can do the same thing with the data that we're collecting, because we're basically now taking unstructured data and structuring it in a way where we now have, here's a car, here's the car that's coming through the scene, here's how long it's been in the scene. So now when you aggregate a ton of that data, you can actually apply, you don't need to apply deep learning, you just apply machine learning to that same data set and go, okay, now give me a prediction that based on the flow, like what is the average speed, what is probably the prediction of how many vehicles will probably go through this intersection at this time based on all the past historical data. I think all that is possible, and that is where it's going to be very powerful, because I think for the longest time I've heard so many companies talk about behavioral analytics and predictive analytics, and I think this is really where it's going to be I think really attainable. I think now that with everything that we're getting from video and images, and taking that unstructured data, making it more structured, the predictability, the behavioral stuff, tying that with other data sets. And that's why it's for me, I was excited with the way large language models and all these other models have gone multimodal, because I think that's the biggest thing. That's the biggest thing, is trying to correlate so many other data points to correlate. And now you're going to have the ability for the security industry to really look at behavioral analysis and create those predictions. I really think that's very possible with the amount of data that we're collecting now. And it just comes down to who's going to make it easy. Who's going to make it easy to do it?
So I have one example of just doing exactly that. So I was visiting a small village close where I live. And collecting, they were mainly trying to understand how many cars, vehicles passed by ever there. But since it was a radar, it's also speed. So I'm collecting the radar data. And then I started, what more can I do with this? Can I graph? How can I graph this? So I took I took an array of 0 to 100 kilometers an hour, 0 kilometers an hour, 1, and then just collecting all this data, and was a maximum speed that this object had during its going through. It was like 55, and then 55 got +1. So I got one of these, just not bell curve of what are the speeds. And I showed this back to him, and he thought, this is really interesting. Now we can see the big variations, and we can see the common case. He showed this to the police, and the police says, oh, this is really interesting. I wish we could get the data that when should we come up there with our speed radar. And it says, I can do that because I have the data. So I'll do the same thing. So took all the speeding. And then hour of the day, like right after midnight, one after 1 o'clock, 2 o'clock, 3 o'clock, and just adding these up, and says, okay, so it's between 7 and 8. And then did the same thing with weekdays, because I had like months of data, weekdays. So I said, well, if you want to talk to the police, and when they should stand there doing radar, it should be Monday morning between 7 and 8. So, so like one good example of how you can, once you have the data and collecting the data, how you can add more use cases on top there.
And actually talking about traffic, a really good one that we actually just published in the US was a use case with the University of, I think it was Tennessee, Vanderbilt University. They put a whole series of PTZs to monitor the highway, and they were monitoring traffic along there, congestion on there, and also the express lanes, to the point where they were looking at like the flow of traffic, accidents, and then they were also using autonomous vehicles in there to kind of slow traffic down to see if they can make it more efficient. And they capture so much data on just the vehicles and the vehicle flow, and they graphed it visually. And I was like, this is exactly where this technology is going, where you use the images to detect the vehicles, and then really the data is in the vehicle, right? Like the vehicle flow, how long it's been, how fast it's traveling, and then now you can start to do predictive behaviors. Then you induce a controlled environment with these autonomous vehicles to slow traffic down to see if that helps flow traffic, and then that gives them ideas and hypothesis on, can we improve traffic, right? So I think that's where the data becomes very valuable, right? Like everybody talks about, oh yeah, I need to see this and that, but really it's in the data that you're collecting on how these objects and these things are traversing the scene that becomes even more valuable. Yeah.
But yeah, and getting data is all about sensors, and the camera is, there are tons of good sensors out there, but there's stuff that you have to have camera, you have to have analytics, but and then turning that camera into a sensor. And then it's all about how can I get that data from point A to point B in a consumer friendly way, depending on the use case. It's
cool.
So, and that's what I've been looking into very much.
Yeah, no, that's awesome. That's good stuff. I definitely appreciate your time. This has been a really good conversation, just talking about the models, the training, and then using them with the cameras and everything. I know we can go on, and there's other topics that I also want to cover next time, that are very exciting to just the advancements of camera sensors and computer vision and drilling down to the data, because I think all that could be another segment in itself, talking about spatial data and all this stuff and replicating the real environment in 3D. But yeah, no, I definitely appreciate your time, Fred. Thank you for contributing to this series. As I was telling you, I chair the ASIS International Emerging Technology Committee, so we're always looking for good content to just share with the community, to talk about just technology as a whole, and just to get people to understand the technology a little bit more. And this type of podcast and conversation that you and I are having is exactly it. We like to do a lot of these where we're just talking to just technology folks, and just talking about what are they doing, how are they doing it, how are they applying it. So definitely appreciate that. I want to give
applying the use cases and understanding what was the use case, what was the job to be done. You can, but thank you very much. I really appreciate.
Cool. All right.